Well, thank you everybody for joining today. We're going to talk about something that is actually very important to me and something that I have become very enthusiastic about because I didn't realize it was a problem when I was building it the first time. And then I built it a second time and still didn't realize it was a problem. Then I built it a third time and realized, oh crap, this could have been way, way easier every single time I've implemented it. So I want to talk about real-time notifications. Now, the title of my slide or of the whole thing is WebSockets don't have to be hard. And part of the objective of what I want to do with us today is kind of level set on what real-time notifications are and also what they are not and what people may or may not incorrectly call real-time notifications because there's a lot of misinformation around and just leading to the difficulty of the concept in general. Because as we push and modernize our applications in the cloud, real-time notifications become more and more relevant, and they're just kind of expected to be there. And if they're not, then your customers feel like you're falling behind a little bit. Before I go on, I do have a live reaction, interactive piece to this entire slide, and I am realizing now that this QR code at the very bottom, you may or may not be able to see it, is pretty small. But if you can scan that on your phone, great. What it does is it'll take you to a page that has little Momento branded emojis on it, and as I say things that are cool or mind-blowing, or one other thing, I forget what it is, but you can react and you can push the buttons and it will send your reaction across the screen. Now, if you can't scan that, because it is pretty small, Kelsey's picture, oh yeah, someone found it. Kelsey's picture, if you can see her video, is a QR code for it as well that can take you there. And I'm hesitant. Yep, more people. Okay, great. We're finding it. This is cool. Okay, I'm pretty sure everybody's found it, so I don't need to talk about this anymore. So glad today that I built in the turn reactions off functionality because I just don't trust all of it. Yep, look at that. This is gonna be fun. Okay, let's go. So let's talk about what we're going to talk about. So we're going to be talking, of course, we're here. It's a Momento event, so we're going to talk about Momento. Then we're going to level set on what are these different terms that we use when talking about real-time notifications, because that's really the foundation for everything that we're going to be talking about after this. We're going to talk about the architecture and how you build one of these things, how you've probably already built one if you're anything like me. We're going to talk about the options that you have and how specifically to build a production level notification system. And then we're going to talk about the cool new way to do it, the easy way with Momento topics. Then we're going to transition over to a handful of really cool things that you can do because it's so easy now and so connected. And then last and probably most importantly, we're going to talk about cost, because anytime we talk about SaaS providers and cloud, cost is always top of mind for good reason. So we're going to run through a couple of different scenarios and talk about how we price this thing out. So about Momento, I think hopefully you all have heard of Momento before, but really our motivation is believe in serverless. Let's empower people to build as fast as they can with enjoyable experiences, and let's do it where we take the undifferentiated heavy lifting off of developers so they can really focus on the business problems. It's kind of our guiding lights. And we started off very modestly with caching. We had one thing that we did incredibly well, which was caching. There was a gap in the space that we filled, I'm pretty sure by ourselves, for serverless cache. There's no configuration, it just works. It's super fast, get and set in like literally 10 seconds. You can go to the website and do it, and sign up, create a cache, and put items in it in like literally 10 seconds. We're going to talk about topics. It's a service that we released earlier this year, which is serverless event messaging. And there's a whole bunch of different terminology that we can use to talk about it, and we will. And then back in August in Momento's conference, MoCon, we announced a new service, a third service of Vector Index. which is for your AI-powered apps and RAG pipelines and all that fun stuff. So we're growing, we're doing things serverlessly and fastly, and really these are the things that when you use one of our services, you can count on being there. You can count on them being serverless. You can count on them being fast. You can count on them being secure, probably the most importantly being secure. But really, you can count on them being simple as well. And that's one of the big things I push for here. That's one of the big things that I do as part of my job. But we have an entire team dedicated to SDKs and developer ecosystem that live and breathe simplicity and developer experience. It's a great team to work with, and I'm super excited about the efforts, the intentionality that we put in to making things work and work easy and scale. So a little bit about me. I'm an ecosystem engineer here, which is a fancy way to say developer advocate. So that means I am here to build cool things, show you cool things, and then talk about cool things in different ways. So blog posts, videos, presentations like this. I'm an AWS serverless hero as well. So I've been writing and creating content for like 5 years, all around serverless. That was way more distracting than I thought it was going to be. The comments up on the screen. I run a blog post or a website. Really, I can't even call it a blog anymore. It's Ready Set Cloud. So if you've ever seen anything from there, it's a blog, it's a weekly newsletter, it's a podcast as well. That's all me. That's the brand that I've built and shared my journey from what is the cloud to here I am today. And I have built a WebSocket system before, and it sucked. And it didn't provide a lot of value for the amount of architecture that was involved with it. And I don't want you to do the same things, which is, again, why we're here. And before we get into anything, we're going to talk about a few things because I've used words incorrectly. I've seen other people use words incorrectly. We're going to stop using them incorrectly. So we're going to talk about WebSocket, the title of the whole thing. The title of the whole talk is incorrect. WebSocket is a very specific implementation of real-time notifications. It uses the WS protocol, stands for WebSocket, or WSS if you want to be secure, which you should. It is a stateful communication mechanism that enables two-way talking. So stateful, meaning it's like a phone call. Or like my example there, it's like a walkie-talkie. So you call your friend, you're on the phone, and you can talk. One person talks, the other person immediately hears it, can respond again immediately. If one of those people walks away from the phone, the other one is going to know that their friend isn't there. It's very stateful. And that's important. That's a very important distinction when talking about real-time notifications because it limits technically what you can do in some situations. But WebSockets are probably one of the most popular mechanisms out there when we're talking about browser to server communications. Now, a lot of people confuse WebSockets with push notifications. They say, well, WebSockets, that's push notifications, right? I can send a message to a mobile phone. Not really. They're not the same thing. WebSocket, in that sense, is not the same. A push notification starts at the server and ends on the client. So it's a one-way direction for real-time notifications. They're also stateless. So if we use our phone analogy again, if you have two people talking to each other, then you have one person says something, the other person leaves, you'd have no idea. It's more of like a, let me call you on a phone book or let me send you a letter, because you don't know when that person's going to get the answer. You don't know anything on the other side either. So it's a stateless implementation where you don't have to have everybody connected. So last one I want to say here is real-time notifications, which really is what this talk should have been called. Real-time notifications. So it takes the best of both worlds in the sense that these are event-triggered notifications. They go both directions, and it focuses on publishers and subscribers. Notice I don't say browsers and servers. It's very different, but super fast, immediate communication that can go either direction. So this would be, I don't like reading off slides, but I really thought that my explain like I'm five on this one was funny. So it's like if somebody rings a doorbell, your dog starts barking, and then pizza delivery man says, "It's pizza," and you say, "Hold on, I'm putting away the dog." Yeah, or hold on, let me put away the chicken. Exactly. It's that kind of thing. That's a real-time notification where it goes both directions. So let's talk about how you build a microservice that handles notifications. And I see that Andres is on the call, and he was on my team when I did this last time, and can vouch that it was not fun. It was a lot of work, and didn't. I mean, it worked some, but let's talk about some options first. We're gonna talk about some of the options, and I have a little pyramid in here because I'm pretty sure this is like most used down to least used, and it's not a complete exhaustive list. I'm an AWS hero, so that means a lot of my examples generally are in AWS. That's where a lot of my experience is. But you have AppSync, which provides GraphQL subscriptions. You have API Gateway, which gives you actual proper WebSockets. You have IoT Core, which lets you communicate with devices up to a server over a different protocol called MQTT. And then you have something called Pusher Channels, which is like a managed WebSocket. So all very different. But I've talked a couple times about how I've built this before, and I've built the one with API Gateway. So what we're going to do is we're going to look at what I built with that, and we're going to see all the different moving parts with API Gateway and how you would actually build that. So here's the simple architecture view of what you'd build if you were implementing WebSockets with API Gateway in AWS. And there's two really main parts into here. Really, there's three because there's several things that you have to do. But the left-hand side is connection management. So that's dealing with everybody who is actually connected to your WebSocket. So you would pass up a JWT or some sort of token when you're hitting the connect endpoint on a WebSocket. And that would be fronted by Lambda authorizer. That's what I used for my validation. It validates the JWT, and then it loads some information about the user, and then it creates a context that returns things like user information, user ID. Very fun stuff. Then it goes through, hits a Lambda function, and it saves information in DynamoDB. So if you look over on the right-hand side, you can see my little data model there. So when you connect, it creates an item in DynamoDB that says, here's the connection ID. API Gateway creates a connection for you and gives it an ID. I call it a connection, and then I also map a user ID to that. So I can actually uniquely identify the person based on the connection that's come in. People also want to know, they want updates on very specific things. So let's say I have a chat room. I want to see information. I want to see new messages when messages come in the chat room. So I can subscribe via the WebSocket to the chat room. And what that ends up doing is it saves another item in DynamoDB under this GSI here. Maybe I'm in the chicken chat or the goat chat. And it's basically saving the topic that I want to publish to. So I have this whole thing, then I have disconnect, and when somebody actually disconnects and breaks that connection with API Gateway, I run a query on DynamoDB, say give me everything for this connection ID, delete it all. And we clean that up after ourselves. All of that, so that's 1, 2, 3, 4, 5, 6 items on our architecture diagram. That's just for connections. That's literally just to connect and disconnect to the WebSocket. There's no business value. I can't send a message. I'm only connecting to it. And I've had to build all that. And I've had to figure out what are all these resources that I need to create. It's a whole mess. When I actually want to go and send a message to that connection, actually use it, then I have this workflow that you see on the upper right, which is triggered by an event bridge rule, pushes it to a queue. That queue is polled by a Lambda function. That Lambda function will then look at the event that's come in. It'll say, what topic do I want? It'll query DynamoDB on that GSI to say, give me everybody who cares about chickens. And then it'll iterate over every one of those records, getting the connection ID, and then posting the message through API Gateway. So it's a whole thing, right? And of course, there's SQS in there for dead letter queues, but it's a whole thing. And that's the simple architecture, simplified view of building a WebSocket with API Gateway WebSockets. So when we actually want to send a message, so when we do actually have people that are posting about chickens or goats, like what's the flow? So I have up at the top, this is something that would maybe live in a different microservice. A very basic serverless workflow here. API gateway, Lambda, save that data in DynamoDB. And then from there, we've gone async. We've returned a response to the user, you're good. Your post on chickens has been successfully saved. Then we kick off a DynamoDB stream to a Lambda function, which processes that information, indexes it into OpenSearch, and then subsequently sends that message or puts an event on the event bus. So you can see how all these things are flowing. We've already described what that posting to connections workflow is like, but it goes boom, boom, boom. And that's a lot. That all this to say, hey, somebody just sent a post on chickens. Now, as cool as that is, it's a lot of work. It's a lot of work. It's a lot of things to maintain for what I consider very little business value. And I know I get a lot of flack when I say that, but bear with me on that one. Let's look at a slide here. So all of that, just summing everything up, it's 7 different Lambda functions that manages all the connections and actually posts to them. It's almost 600 lines of CloudFormation. It's 12 boxes on my architecture diagram. And again, it's that one piece that I can send a message down, and that's just the server side implementation. It's not even the client side. So I say it's kind of functionality. Some consider it business functionality, some don't. I say it's capability. It shouldn't be lumped in the same. If you're interested, I do have the source code for all of that available publicly in GitHub. Now, I think I mentioned earlier, I've been a writer for about 5 years. I've been blogging for 5 years, and WebSockets are my only blog series that I've ever done. I had a 5-post series on building WebSockets. Everything else has been one-off. And why is that? Because they're freaking hard and there's a lot to them. That was the only thing that I found that I could write about and write about and write about and still find more things, because there's just so much to them. It's a great capability, but there's just so much to it. Okay, whew, let's take some water. I'm all riled up because I'm living battle wounds from implementing that last time. Okay, so let's talk about the right way to do it. Architecturelessly. You can quote me on that one. So using Momento topics, which is our serverless service for event messaging, I would consider it a serverless or a managed real-time notification service. We released it in March. It's available in 5 of our 10 SDKs. We're still working on the other 5. It's available over our HTTP endpoint as well, or our HTTP API. You can publish to a topic. And instead of WebSockets, I don't want people to confuse topics with WebSockets. Instead of the WS protocol, it uses gRPC, and we'll talk a little bit more about that here in a minute. But it scales really, really well. It has a 2-tier architecture where layers are. That's a whole other talk. We'll actually go into that at a different time, but just know that it scales highly. I have blog posts on it. It's super, super fast, and that's also a result of that 2-tier architecture. And again, it's super easy to use. So that's one of the things that I'm really going to push, how easy it is to use as we continue going on in this presentation. So I've already mentioned this casually before, but when building with topics, your focus shifts considerably. You don't have to focus on the pieces of infrastructure that you're routing data through. You don't have to focus on dead letter queues and failure mechanisms and disaster recovery. You just have to focus on, well, who's publishing stuff and who's subscribing, who wants to publish, who wants to send a message, and who wants to listen to that message. And that's about it. That's where your priorities are. It's on connecting the dots in your business workflows, which is what every developer wants to do. It's, let me just code it, which is awesome. And let's talk about how that is. So here's our nice, lovely workflow with WebSockets. And like I said, there's way too much here. way too much for getting a message from that girl to that guy in the top hat. There's too many things. So let's ignore that. We're going to take that entire microservice away. So not only are we taking these 12 boxes away, we're also going to take connection or notification microservice out the door too. We're actually just going to kill that entire repository. And instead, what we're going to do is focus on building something architecturelessly, at least as far as diagrams go, and at least architecturelessly that you care about, because you don't own the architecture, you don't own the infrastructure, you're just communicating with third-party service. So here's that workflow we were talking about earlier. API gateway, Lambda Dynamo, stream, Lambda function. And then that Lambda function does two things, where it indexes the data into OpenSearch, and then it also publishes an event down to that microservice. Well, we don't want that, because one of the best practices for Lambda is principal of least privilege. That Lambda function is doing too much. We need to make it stop sending those events. So what we're going to do is we're going to keep that Lambda function, but we're going to say you're only for indexing into OpenSearch. That's your thing. But instead, what we're going to do is we're going to hook up an EventBridge pipe to an API destination. Now, for those looking at this list of attendees, I'm pretty sure most of you are really good with AWS, but just in case that you're not, let's very high level. EventBridge pipe it connects services together in a very easy, resourceless way. So you could say, give me the raw data from DynamoDB, transform it, and send it off somewhere else, without using a form of compute like Lambda. Caveat there, I know that you can use Lambda if you want to do the transform. But we can also use an API destination. And an API destination is something that EventBridge has natively that calls a third-party HTTP REST API that's available online. So what we've done here is we've published a Momento out of Lambda, and instead we said just call this API destination instead to our publish endpoint. So there's no compute code that you're working on. You're doing a transform in a very small pipe, and you have an API destination. What that looks like as far as the business flow goes is you have our subscriber down here, and he has his 3 lines of code. Based on your style guides, that could actually be 1 line of code. But for the example, it's 3 lines of code. And all he's done is he said, subscribe to my farm animals namespace, to the goats topic. So every time a goat thing comes through, I want you to run my handler function, my code, with the value out of here. And that's it. And when he runs that connects him with a gRPC connection to Momento topics, that third-party layer that Momento handles everything for you. You don't have to deal with any of that. You don't have to deal with any sort of networking at all. It's just there. And then when this lovely lady over here on the left-hand side posts her story about goats, that works its way through the pipeline, eventually making its way through the pipe to transform the data to our HTTP format, and then that posts to the topic service, which then pushes that data down to that man. So you've actually implemented that fully on the server side with no compute. Really, that's no code. That's like 1 infrastructure resource for a pipe, and that's about it. So over on the left-hand side, highly recommend you look at our EventBridge API destinations. That QR code will send you to the documentation page that we have for our integrations, which has a one-click deploy stack that will install all of our endpoints in our HTTP API into your account, into your AWS account for API destinations, and also create API or EventBridge rules that trigger those API endpoints. So all you have to do is just drop an event and you can communicate with our services. Super cool. Okay. Another thing that's important to note, we'll talk about this in more detail in a minute, but it doesn't matter where you call that subscribe code. It could be a browser, it could be some stateful cloud service, or it could be some container in some pod and some node in a Kubernetes cluster. It really doesn't matter, as long as you can get that HTTP connection out to the Momento services, you can connect it. So it's way more versatile than something like WebSockets or server-side events. And again, we're going to talk about that more in a minute. So I can't talk about all this without talking about security. Very important thing. We're always hyper aware about security and how things work. And with our services, we have two different types of security. We have API keys, which are uh, long-lived access tokens that give you the ability to hit our control plane. So things like create a cache, delete a cache, do things of that nature. And then we also have tokens, which are short-lived, limited scope uh, um, access keys, basically, that you can pass down to clients that only have access to data operations. So things like publishing and subscribing or getting and setting values. And so what those look like when you're talking about these tokens that you're passing around, we're talking about fine-grained access control. So inside of your token, you have baked in permissions that you can set that limit the scope down, basically, that say you can only have access to read this specific cache or publish only to this specific topic. And beyond that, we also have a really nice capability that lets you do key prefixes and topic prefixes. So let's say you have a multi-tenanted cache or a multi-tenanted topic, and you can say, I only have access to cache keys or topic names that start with my tenant ID. Very nice that you have that built in right away. So anytime you try to hit something that's not in that token, you'll get a 403 and you're not allowed to do any of that. So really nice. And I'm not going to spend too much time on this because we're going to continue talking about it the entire rest of the time. And we're going to be talking about it through some cool things that you can build. Like there's some really fun stuff because of the connectivity that you have with topics. There's some really cool use cases that we're going to talk about. So the first one, we've been looking at it for 30 minutes already. It's this entire application that I'm presenting from. So really, this is nothing more than a web page that I made that has an iframe pointing to Google Slides. That's really all that it is. And whenever you are on that page, the presentation / React page, you are publishing to a topic to which this screen that I'm on subscribes to. So you send a message, my browser picks it up, and it sends one of those emojis up over the screen. And you can see here that I have the auth different on both pages to create different scoped permissions based on who I am and what I'm doing. So when I'm on this page, when I'm actually going and presenting, I get a token that says I can subscribe only to the topic for this presentation. If I try to use this token to do another presentation, it's not going to work. If I try to use this token to send one of those emojis, it's not going to work because it's subscribe only. Conversely, the page you guys are all on, trying to distract the crap out of me, it's publish only. So you notice how you don't have emojis floating up on your screen. It's just me. I knew I was going to pay for that. You only can publish. So if you tried to subscribe and get the emojis up on your screen, it wouldn't work. So this is a really cool example of a browser-to-browser implementation of what you can build. There's no server-side components besides creating those tokens. That's it. There's no AWS backing resources. This app is built in Next.js, so the server side is just the server-side components for Next. Everything else though, just Next. It's just front end. I didn't have to build any of that connection management myself. It's just publish, subscribe, 3 lines, 3 lines. Super nice. Another fun example is fantasy football. I think most of us, probably not all of us, but most of us are Americans, so we've all heard of fantasy football. And it's a point tracking app. You know, you get people on your team, and they are real people that play real football and real games. And based on how they do in the games, you get points and you compete against each other, and it's super fun. So you can build a fantasy football live score tracking app with topics. So what would happen? You have a bunch of people with your app on their phones. And whenever they load the scoring page, you could run some code like this. Iterate over all the players on my team and subscribe to their dedicated topic inside of Momento topics. Whenever you get a message on that topic, then I can hit this generic update points function that I wrote in my code that has the player ID and the number of points that that person just scored. So I can go in and update their running total. So what does that look like as far as the data flow goes? Let's do that. So Patrick Mahomes throws 44 passing yards. So whatever system is out there that's pushing the data from the game into the fantasy football engine is hitting that post to the /stats endpoint saying, here's the player, here's what they just did. And that goes through, hits a lambda function, does some transforms, figures out how many points that relates to, and saves it in a DynamoDB. And so we saved it under that player ID, and then we're doing a chronological time. Here's all the stats that they've scored for this game. Good to go. So down in the standard workflow, what we've done is we've created a pipe that does a transform. So the pipe receives that data specifically in that format, and we say, okay, that needs to change, so we can hit the topics endpoint, the post inside of the Momento HTTP API. So we've transformed that data to go to topics /American football / the player ID and pass the value of 1.8. And so as soon as we do that, everybody that's in the app right now, because it's a stateful connection, gets that 1.8. And that update points handler is going to say, okay, Patrick Mahomes plus 1.8 points. So I'm good. So really easy. It fans out incredibly well. And it responds super fast, so you can get that in real time. So this is an example of a server to a browser connection. So we've done browser to browser, we've done server to browser, again with the same code. It's the same 3 lines of code, very minor implementation details in there. So let's talk about server to server, and we're going to talk about my absolute favorite cloud infrastructure. We're going to talk about Kubernetes. So we have 2 nodes, and inside of that we have 2 pods each, and inside of those pods we have 2 containers each. And what we want to do is we want to manage feature flags. By the way, I didn't see any reactions when I said Kubernetes was my favorite, so that was a joke. Can you guys like throw some reactions up or something? Thank you. Just wanted to make sure that we knew I was joking on that. Okay.
This session is recorded, right, Ellen? So we have it on tape. That
but you also have this part. You also have this part that was, yeah, okay. That's gonna be taken out of context on me. Okay, so we have Kubernetes, and we want to keep everything in state. So in this very small example, we have 8 containers out there that all have a feature flag configuration object. It has maybe 20 different feature flags that you're tracking. And based on that, you know, the code deviates based on what the feature flag says. So on startup, each one of these containers is going to do 2 things. One, it's going to get the entire configuration object for feature flags out of a cache. So we'll use Momento cache for this for obvious reasons, and it'll load that entire object. The very next thing that it does is it subscribes to the feature flag update topic to say, whenever I get a message on this topic, I'm going to go ahead and update my feature flag configuration object. So I'm going to be receiving deltas. I'm going to be receiving the feature flags that have changed, and I'm going to update my big feature store. So that's what these containers are doing on startup. So what ends up happening from a business point of view is you have your feature flag dashboard, which is usually a browser-based thing or a graphical thing. So you can hit toggles to say, yes, turn this feature on. You can configure rollouts for you know, canaries on very specific features. But what happens is you hit a toggle, that hits API gateway, it goes to Lambda. But instead of our flow that we've been doing, we're just going to stay with cache. We're just going to keep, I'm getting pecked. We're just going to keep everything in the cache. So it's going to update the cache, and then simultaneously it's going to then go out and publish that change via a, via a topic. So if I said goat stories on, it'll publish goat stories on, and all of those containers in that entire cluster will be kept in sync immediately. If a new pod comes, or a new container comes up, or maybe one goes under a network failure for any point in time, you can always reload the entire object out of the cache. So you can get back to current state. because this is only sending you updates, not the whole thing. Here's a fun one. I think this is the last one that we're going to talk about. And that's chat. This is a very easy, approachable use case because everybody has chat. I was on the Home Depot website the other day and I had a chat bubble pop up that asked me if I needed help. Like even Home Depot has chat nowadays. Everybody has it. And this guy keeps picking my ear. This was a bad idea with the chicken. Anyway, but this can be a completely browser-based thing as well. So kind of like that first example that we had. You're going to see the same patterns emerging because it's such a simple architecture. It doesn't matter where you're publishing and where you're subscribing or what your workflow is. It's usually about the same three things that you're doing. So somebody logs into a chat. Let's see what code I have. Somebody logs into a chat. What they're going to do is say, give me the entire chat history from everything that was said before I got here. And again, we're going to save that in the cache. We're going to save that in a cache object inside of a list. A list is one of our data types that we have inside of the cache that stores things chronologically. So I can push things in order, which is exactly what I want when I'm talking about chat. So I get the entire history. I save that. We're going to pretend like this is a React app. I save my React state with all my messages in there from the history. And then just like I did before in the feature flag thing, I'm going to go ahead and subscribe for updates. And what happens on the other end, after I've logged in, I've got the chat message history, and I actually go and type in a message. It couldn't be simpler. All I'm going to do is stringify the username and the message, and then I'm going to push that onto the list in the cache and then publish that. So everybody that's inside of that room can immediately get the message that I sent. If we go back to the subscriber, it will parse the message that I just sent and display it kind of like what you see down here with Mo and his instant messenger. So what I want to show as well here, because we've already kind of talked about that pattern, but we didn't talk about how the auth works with something like that. So this mechanism does both cache and topics. So on the server side component of this, where we're creating our auth tokens to pass down, we have read write for chat history because we need the read when we sign in and we can get the full chat history. We need the write because we're pushing the messages that we're typing in there. And then we also need topic permissions as well, publish and subscribe, that allow us to send messages across and receive messages across that same topic. So that's what a minimum set of permissions look like. And you can see that we've done item level for cache, item level scoping. So you can see we've said you can only read and write to this one specific key in the cache. And that one specific key in the cache refers to the chat mess or the chat room that we're in a part of. Very cool. Very cool. So chat, everybody uses chat. This can be reused everywhere. One thing that I want to talk about, because every single one of these examples, I've talked about auth, and that's the hardest part. It's the part that actually requires server-side changes, but how much? And if you're already using AWS infrastructure and you're already building something with things like Lambda authorizers, it's a very low lift to actually get this in there and working. So again, this comes from a pattern at my last job where all of our microservices were fronted by a Lambda authorizer, and that Lambda authorizer would do two things. One, it would validate the JWT. Is this valid? Is it expired? All that. But it also loads that user out of DynamoDB and provides contextual and role-based authentication mechanisms back to API Gateway. And what's cool about that is that you can also enrich the context that goes to downstream services in AWS. So based on the JWT that comes in, I can get information about the user. I can get things like the user information, the roles they have access to, and pass that to step functions in Lambda and EventBridge and Dynamo. But if you're actually going in and trying to implement Momento topics and cache into your systems, well, you can actually just throw it in there in that Lambda authorizer. if you're doing role-based systems and you load the user and you know what roles they have access to, you can immediately generate a token scoped to the permissions and the cache items and the topics that that role also has access to, that tenant and that role. And you can pass that token, max life of an hour, down inside of the context, and you can use that from the context, basically a claim at that point, in all of these downstream things. So if you need to connect to the cache when you're working on a Lambda function, you can just say event dot request context to authorizer dot memento token, and boom, you're there, and you have permission scoped to what the caller has access to in all of your backend services. But here's the coolest part. I don't like generating tokens when I don't have to. If I can get by with just generating one, then I will. More tokens, that means the more opportunity to get compromised. So a lot of APIs will have something like a user info endpoint, which stores and returns information about the user. Like usually it's their profile information. Sometimes it has additional claims in there. But what you can do is you can take that Momento token out of the authorizer context and just spit it back in the user info as a claim when you're calling that from a browser. I know that part might be a little bit confusing if you haven't done it before, but the end result is really, really cool because you've given your front end access to that token that was generated for you for that session that you're signed in. So your front end can now access the cache and access topics with the same exact token that the back end is also doing things on your behalf for. So you've generated one token and you can access the same things in the front end and the back end, which, you saw everything that we just did with all of our examples. You need that. So it's super, super cool. Okay, we've talked about examples, talked about auth. It's really easy to implement. We're gonna talk about the part that's probably one of the most important things. We're talking about SaaS, talking about cloud. How much does this cost? Because if it costs my arm, my leg, and my firstborn kid, I'm not gonna use it. I don't care how great it is, I'm not gonna use it. Now I did hide this in the topics bio slide earlier, but we're gonna make it more prominent now. And that's 50 cents a gig for data transfer in and out with a free tier of 5 gigs every single month. So every single month you can transfer 5 gig of data for free. Now, that's really nice. And part of what I did at my last job is a lot of cost modeling, especially with serverless. It's hard. And I can see this all day and say, okay, that sounds great, but it doesn't really mean anything until I run practical examples through it. So let's do that. Let's run some practical examples. So we're going to talk about online support. So your basic chat app. So I'll give some context here. You have an online chat app that is basically support, tech support, and you have 10 agents at any given time. The calls with your customers last about 15 minutes, and they send about 75 messages total. The messages are about 150 bytes. So I'm not going to walk through all these all the calculations and whatnot. But what that ends up being is 5.5-ish meg of data transfer a day. And if we multiply that by 30 days, then we realize, well, holy cow, that is way under the free tier. I can build an online support app for free every month. And that's 8 cents. So even if I'm not under the free tier, that is literally pocket change. Now, another thing that I want to talk about before I move on to the next example is the other things that I've included in these daily calculations. So you can see in here that I have 15,000 connection minutes and 37,500 sent messages. Now, we didn't use those for how much it costs to use topics, but you can use those to price comparison everything else that does real-time notifications, because everybody else charges connection minutes, data transfer, and sent messages. They charge for 3 things. So I've enabled you. I personally don't like doing the side-by-side comparisons like that. It's I don't just not my thing, but I will give you the tools. I will teach you to fish and you can go fish. So There are the other things that you can use to price out the other options that are available out there. I can tell you for sure it is not less than 8 cents. So let's talk about number 2. So we've gone from a really small application to a big one, a social media website. And everybody on the social media website, super active. It's like every social media website builder's dream. So you have 25,000 active users. Everyone's online for 2 hours a day. And when they're online, they're posting like, they're liking like 20 posts, they're doing 5 comments, and then they're publishing to their story once per hour. So, you can do the math there. Now, the reason why this is a good example is because notifications, real-time notifications scale up very quickly depending on use cases. So you do a like or you do a comment, you have a one-to-one notification. That's me liking your thing. So you get a notification when I like it. Same with the comment. But if I post a story on my profile, I want everybody to see it. So I will then have to do my one notification, fan that out to my 200 followers, and I now have 200 notifications. So you can see how that escalates very, very quickly. So we're just going to assume that we've kept notifications down to 100 bytes, and we're sending, how many is that? 135 million messages a day with that type of workload. That's a lot. That's a lot. And that results in 13.5 gigabytes of data transfer every single day. In a 30-day month, that ends up being 405 gigs of data transfer. So we've taken off the 5 gigs free tier, and then we have 400 gigs left that we have to pay for. 50 cents each is $200. So you've successfully implemented a real-time social media app for $200 a month with 25,000 monthly active users that are very active. Very good example of how powerful this service is and how cheap it costs to run. The last example that we have is an online store, e-commerce. You have a bunch of people in here. There's a whole lot to this one, a whole lot. I'm not going to read the whole thing, but the big things to know is that you have a 5% conversion rate, which means 5% of the people that visit your site actually buy something, and you have a 10% help rate. So 10% of the people that come to your shop ask for help in some way. Maybe they're asking for a refund. Maybe they're asking where's my package. Maybe they actually just need help with something else. So with the 500 daily concurrent users, all the math rounds out to where are we at? 60 megabytes of data transfer. Hopefully I did that math right. But there's a whole lot to it, right? You have to track inventory in real time because you don't want people buying stock that doesn't exist. Let's say I bought the last one. I don't want Quadra to turn around and try to buy the one that I just bought. So you have to do these real-time inventory updates to block that from the browser. Anyway, all this to say, there's 381,000 support or connected minutes every single day. There's 400,000 messages sent every day, but you don't have to pay for that. You're paying for the 60 meg of data transfer a day, and that's it. Which, push comes to shove, down at the end of the month, you're being charged 91 cents. Oh wait, you're not being charged anything because that's under the free tier. So super cool, super nice. Ah, man, chicken landed on my water bottle. I can't drink water anymore. Okay. So let's talk about what we talked about. We're just going to do the summaries here. Back on the water bottle. So the one of the biggest takeaways that I want you to have here is not Momento related. It's just terminology related. Don't say WebSockets when you mean real-time notifications, because WebSockets is a very implementation specific term. It means WS protocol, two-way connections. You're managing the connections yourself usually. We learned how cool Topics is. It's super fast, it's serverless, it's cheap. Well, that's actually bullet point number 4. Super cheap to run. And then because it's so connected, because it takes same code to connect two browsers together as it takes to connect two services together in your back end. Same to connect the service on the front end. You can do anything. Everything needs to communicate all the time. So as long as you have a stateful connection on these anythings, then you're good. So I know there's a lot of serverless people in here right now. Lambda is not stateful. So you can publish a message from Lambda, but you cannot subscribe meaningfully from a Lambda function. Once the Lambda execution is done, and this applies to any serverless function, right? It's not just Lambda, it's all the other ones too. Whenever that Lambda function or serverless function execution is done, it shuts off and that connection breaks, and you're not going to be able to receive updates in real time. That requires a stateless connection, not a stateful one. But everything else, browsers stateful, containers are stateful. There's a whole lot of stateful compute out there that you may or may not realize. So that's a lot of stuff, a lot of passion poured into this one. So thank you very much. Please try topics, please. It's so cool. It's so easy. And if you have questions, feel free to contact me. I am happy to talk about any sort of real-time notification at any point in time. This QR code points to our documentation on our doc site to topics that has everything that you want in there. So if there are any questions, we have 5 minutes left. I am happy to take easy ones only. So you can come off mute, or you can just type them on that screen that you're on your phone. I really want to drink water, but it has chicken on it now. Okay, if there are no questions, that actually is very flattering.
I have a question.
Yes.
I want to know that how would you distinguish topics with webhooks? Is it kind of the same thing?
Good question. A webhook is a stateless form of real-time communication. So if you're doing things like server-side events or push notifications, specifically when you're in a browser, what ends up happening is you have service workers, which are threads in the background, that open up a endpoint, basically. And the server will call that endpoint. It will post to a webhook endpoint in a stateless manner, because the two don't have to be connected at all. You can post to it, and the receiver of the webhook, the owner of it actually, will respond and react that way. So there's no two-way communication. A webhook is a one-way communication, but it's a way for, like a push notification, for a server to communicate with a client.
Got it. Thank you.
Mm-hmm.
Alan, can you talk a little bit about what you sort of know and compare the two protocols, the WS protocol versus gRPC?
Oh man. Okay, sure. Let me see who's still in this. Okay. So the WS protocol is for WebSockets. WS stands for WebSocket, and it is a very lightweight full duplex protocol. So full duplex meaning you can send and receive data at the same time over that single connection. So it's a single TCP connection that connects the subscriber and the publisher together. They're both really publishers and subscribers at that point. But it's extremely lightweight. I don't know a whole lot about gRPC, I'll just be honest with you there. But there are a lot, there's not headers, WebSockets just have a lot less to them. The TCP package that goes over the wire is very small and lightweight. And I don't know how to compare that to gRPC. I know gRPC has the same kind of functionality in the sense that it's also full duplex. It can send data across at the same time. I couldn't compare them meaningfully off the cuff.
Okay, thanks. I was just curious.
So one other thing that I've built into this website, in addition to being able to let you react and post comments and stuff in real time, is that I've also been tracking what you guys have been sending. Yep, all that. Been tracking all that. So let's go ahead and see who has been reacting. Hopefully, well, there we go. Okay. Okay. Thank you, Michael. I know it's early for you, but I'm really glad that you've been heavily engaged with the content. You too, Andres and Ellery. My 100 and above people. So this is built on cache, if you're interested. So whenever the other page receives a notification from a topic, it will save the username and what reaction they used in a sorted set inside of a Momento cache, which basically builds these leaderboards for you. So it stores the score, the rank, and the field, which would be your usernames. So there we all are. Look at that. It's a lot of engagement. Very cool. Okay. Were there any other questions on topics? Is anybody here excited to try them now? Hopefully, yes. There are no reactions on this page, but hope I can go back and we can all give some thumbs up. There we go. Good. Good. And again, feel free to ask me any questions that you may or may not have. Happy to help and get you started.